This next section is going to deal with conversions across the ASCII table. We're going to start off with what I like to call automatic conversions. And so this is you not having to force Matlab to do it. It sort of does it automatically. And the rule goes, and I'll write this out, if there is a string in a vector along with numbers, Matlab treats the whole vector as a string. Truncating all numbers and converting them to characters via the ASCII table. Okay, so let's look at that play out here. Just a few examples. If v equals the vector 65, character b, and 99, well, then Matlab's going to say, well, the user intended this to be a vector of strings, so now I'm going to convert 65 to the letter capital A. B is already a character. I'm sorry, it says this is going to be a vector of characters, so 65 gets converted to capital A, B stays a character, and 99 gets converted to C, to the character C. Okay? And so you wind up with the string ABC. Here, another example. This illustrates the truncating part. So if you have 65.1, B is once again B, and 99 is 99.99. It's going to truncate, not round. And so it truncates this to 65 and then converts it to A. B stays B, and 99.9 gets truncated to 99. So this becomes 65, this becomes 99, and then the conversion happens as it did before, A, B, and C. One more example. So let me make this bigger here. So this example shows that you truncate. Okay. One more example. X equals 65. .5. It's going to be on the end there. This converts to A. You have TLANT, and then this gets truncated to 97, which then gets converted to lowercase a. So you have the string Atlanta. Okay, let's look over to Matlab. Watch this happen. Execute this. Step through. You see that V equals the vector ABC, capital A, lowercase b, lowercase c. Likewise, you see that W is the same because the 65.01 gets truncated to 65. The B remains the same as a string. 99.99 gets truncated to 99. So you get ABC once again. And then X shows you that 65 is translated to A or converted to A. TLANT stays the same, and then 97 gets truncated and converted to A. So if you have just one string inside of a vector with numbers, all the other numbers will get converted to their ASCII code equivalent. If there is none, then there will just be no value there. So they get converted to their ASCII code equivalent, and if there are decimals there, then the decimals will get truncated. So this is a demonstration of how you can manually convert from characters to ASCII. Okay, so how do you manually convert from characters? Well, you force it using either the U, and you will misspell this just as I do, the U int 8, unsigned integer 8, or you can use double. Okay, and we'll look at the types and what really happens here quickly. I'll just leave that up there. Okay, so if I say A equals U int 8, and I give it characters, and it gives me back the integer ASCII code. So if I give it A, a lowercase a, or a space, or a character 0. So what this is going to give me back are the ASCII conversions here. So this is going to give me back 65, 97, 32, and 48. Okay, because it converts from the character to the ASCII code. It gives me the unsigned 8-bit integer. If I go uint 8 and I give it the string TECH, then I'm going to wind up with just each one of these values being converted to its ASCII number. And so I wind up with capital T, which is 84, lowercase e, which is 101, C, which is 99, and H, which is 104. So I'll get that. Once again, uint 8 is converting from a character to its ASCII integer. Go again, if I do uint 8, and if I do come in here and put in just a vector of numbers, uint 8 converts those numbers into integers, as it's supposed to do. And so here uint 8 is going to convert these numbers into integers. Here it converted characters into integers. Here, because they were it converted characters to integers. Here it's going to convert these doubles into integers, and so you're going to get the string 65, 65, 66, because it is going to round here on the end. Okay, but that's only because this vector contains nothing but numbers. If this vector were to contain letters as well as numbers, .7. Oops. Yeah. Get the brackets wrong. Okay. If that's the case, then what's going to happen is now it's going to treat everything in there like it's a character, and it's going to truncate everything. And this is a subtle difference, which is going to take a while to figure out. But notice how now it converts this to 65, this to 97, then it converts this to 65, which is what it did up here when they were all doubles. It converts this to 65, which is right because it is 65. And then, but this one, it truncates and converts this one to 65 as well. And And the reason is because up here, these things were a part of a vector that was nothing but doubles. But once a character got in here, Matlab said, well, I'm going to treat all of these the same because I treat everything in these vectors the same. I assume and force homogeneity in the vectors. And so when it does that, it treats these as if they're characters, and it truncates down to 65. Okay? But other than that, this little thing, which I would worry about a little bit but not a lot, I just really want you to know that Unit 8 goes from characters to ASCII. Okay? Check it out in Matlab over here. Stepping through and setting okay, check it out in Matlab. Here on line 7, we get 65, 97, 32, 48, which is just converting the characters to their ASCII code. On B, I convert those characters to ASCII code. C, I do this. This is a vector of type double, and so I just convert those to integers, which is why I get rounding here in the end. Line D or line 10, since there are characters in here, it's going to now truncate all of these because it's going to treat everything like it's a character, and it truncates just as it did in the automatic case. And so now you see a 65 on the end here. So 65.7 actually got truncated down to 65. And then here on line 11, it translates this string and then treats these as ASCII characters and does the integers as well. Okay, so now let's see what happens when we don't use Unit 8 but when we use double. So when we use double, we get pretty much the same results here. So if I say, let's say L equals double A, lowercase a, space, and character 0, then it's going to convert those to the double, which in effect winds up being 65, 97, 32, and 48. Okay. If I do M equals double, oops, of the string TECH, then that's going to be, once again, 84, 101, 99, and 104. N equals double, and this time I give it 65.12, 65, and 65.7. So I'm asking for the double of doubles, and so that's just going to give me that vector back because this is type double, so it's going to give me 65.12, 65, and 65.7. Which that makes sense because it's of type double. So that's the difference between this and Unit 8. Unit 8 is going to give me integers here, and it's going to round in this case. O, if I have a double, and once I put characters in here, then it's going to behave a little bit differently. So if I put A and lowercase a, and then I do 65.12, 65, and 65.7, right, that is going to wind up giving me the vector. So now it's going to behave just like Unit 8 and give me 65, 97, 65, 65, and 65. because once these characters get in here, it's going to treat everything like a character, and in that case it truncates. Last one, if I do a double, and I'm trying to squeeze this in here, if I do a double on TECH 6597, then I'm going to wind up with going to wind up with this converted and all concatenated together. So I'll get 65, oops, that's wrong. I'll get 84, as I did up here, 101, 99, 104, 65, and 97. All right, let's check it out in Matlab. Okay, so we execute line 13, and you see we get 65, 97, 32, and 48 as expected. We execute line 14, we get 84, 101, 99, and 104. We execute line 15, and since this is a double and there are nothing but doubles in that vector, then it just returns them all as is with the decimal points intact. Because on line 16 there are characters in here, it's going to treat these all as characters and then truncate. And then on the last one here, it's changing TECH to 84, 101, 99, 104. And then you add truncate to 65 and 97 onto it. Okay. Also, I'd like to point out over here are types. For types A through E, they're UNT8, which we haven't seen that before. So we have UNT8s over here. And then for L through P, of course, we have the doubles. So now we're going to manually go. I'm going to do a manual conversion. Convert from ASCII to characters. And what we're going to use for that is the char function. And so if I have Q equals char, and I give it the vector of integers 65, 97, 32, 48, then it will convert that to the string a, little a, space, and 0. Okay? If I have the string, excuse me, the vector r equals char, and then if I put decimal points in here, 32.999 and 48.999, it is going to truncate all that. So that will become 65, that will become 97, this will become 32, and this will become 48. And so then I still get the string a, lowercase a, space, 0. Okay. S, if I did the char of 65, 97, 32, 48, and then I threw some characters in there, it just won't affect the characters, and so you'll wind up with, as expected, a, lowercase a, space, 0, character 0. Let me put there's another space in here, and so then it'd be another space, and then a, and then lowercase a. Okay? And then if I did T, character 65, 97, 32, 48, TECH, then it's going to convert these and then leave that the same. So you wind up with the string A, lowercase a, space 0, TECH. Okay, over to Matlab to watch this work. You have Q assigned on line 7, and it comes out as you can see, and the space is in there here. See the space. On line 8, you see the truncation happen, so you wind up with the same thing with the space in there. You come over here, execute line 9. Same thing happens. You have space here and space here, and so you have these ASCII codes followed by space, then uppercase A and lowercase a. And then you have, once again, the space here caused by the 32, and then the string concatenated on the end. Also, if you look up here, these are all of type char. So now the question is, how do you manually convert a number to what I guess I best can describe as a digit string. So as a string of digits, or also with a decimal place in there, if that be the case. So how do you do that? And what motivates that is the fact that if I had u as a vector, and if I said u equals the char of 97. So let's say I have the number 97 that I want to convert to the character digit 9 and the character digit 7. So my thing here is I have a 97, and that's a value. And what I want to do is I want to convert it to basically this. I want to convert it to a string of characters 9 and 7. Okay? And there's sort of, there are two ways to do this. There is the integer to string and the number to string. And the integer converts integers, and the number converts a number, a decimal number. So here if I do char won't work because this is just going to give me back u equals lowercase a. So that won't work. So this is why there needs to be a function int to string and num to string. And so if I do w equals int to string on 97, then I'm going to wind up with what looks like the number 97, but it's actually, if I do a uint 8 on w, I find out that that's going to wind up giving me the vector 57, 55. Oops. Yeah, 57, 55, which are the ASCII codes for the number 9 and the number 7, excuse me, the digit 9 and the digit 7. Okay? So you don't want to use this, and to sort of omit confusion, and I'll show this in Matlab, but what you don't want to do is you don't want to use int to string on a decimal number, because what winds up happening is, like, if I have z here and I go int to string on 97.7, well, what's going to happen is you're going to wind up with the number 98. And then if you do, oops, it's all wrong. If you do a uint 8 on z, you're actually going to wind up with the vector 5756, because that is the ASCII code for digit 9 and digit 8. So it's going to round for you. It's going to round on you, and you don't necessarily want to do that. Likewise, if I came in here and said vector A equals int to string on 97.3, it's going to round down, and then if I do, that's going to actually give me 97 again. Okay, and then if I did a uint 8 on that, it'd give me 57, 55. So you really don't want to do this when you have decimal numbers. You don't want to use int to string. That's when you want to use num to string, and that just works out much better. As you'll see here, let me go ahead and do the example here before we go to Matlab. Let's say if I did y equals num to string on the number 97, versus 97.5. This should round up to 98, but since I did num to string, what you're actually going to get, and if you come back and do a, it's going to return the 97.5, which looks like a number, but is actually a string. And so to see that, you do uint 8 on y, so y equals 97.5, and you actually wind up with the vector 57, 55, 46, which is the decimal point, and 53. Because now num to string is going to take this number 97.5, turn it to the string character 9, character 7, actually does this, character 9, character 7, character decimal, character 5, and then by doing uint 8, you convert these characters to their ASCII code, and you do 57, 55, 46, and 53. All right, so over here in Matlab, check it out. On line 7, I say u equals char 97, showing that if I try to do a char to convert the number 97 to the digits 9 and 7, I can't do that because it's going to give me an A, which makes sense, because that's what char does. And of course, if I do a uint 8 on char or lowercase a, I'm going to get the number 97 back. I come here on line 9, and I say w equals int to string. And so that's what I use. And you see over here it says W97. But if you go back over here to the workspace, you'll see that W is of type char, and 97 is now in quotes. So int to string turned that integer into a string. And then if I do a uint 8 on that string W, it comes back and gives me the ASCII codes 57 and 55. Right? If I do it on a decimal number here, it's going to wind up with Z. It's going to round. You get the value 98. If you look over here in the workspace, 98 is a type char. If I do a uint 8 on that, it gives me 57, 56, which are the ASCII values for digit 9, digit 8. I do a uint 8 on this variable A, and it's going to give me the number, A equals uint, int to string on 97.3, so it's going to round down, and that's going to give me the string 97. As you can see over here, A is a string type char 97, and then if I do a uint 8 on A, it's going to give me the digits, the ASCII codes for the digits 9 and then 7. Okay, developing that whole thing down here with num to string. If I say V equals the char of 97.5, trying to convert 97.5 into a string, the char is not going to do it because then it truncates and gives me lowercase a, as it should. And if I do a uint 8 on V, it's going to give me the number 97. So on variable V. On line 19, I do an int to string. I try to do an int to string on 97.5, and remember that's going to give me rounding, and that's not what I want. So I wind up with the digits 9 and 8, and that's not what I want. What I want are the characters 9, 7, decimal point 5, and so that's why on line 21 you do num to string if you have a decimal point, and that makes y equal to the string 97.5. You can see over here y is of type character, and so when I do a uint 8 on that, it actually space here, it actually let me run this again so you can see it. If I do a uint 8 on that, it gives me the vector 57, 55, 46, which is the decimal, and 53, which is the 5. Okay? So it takes some working with, but if you just pay attention a little bit and just understand what you're trying to convert, and usually the problem dictates the use of the function, so you don't have to worry about it too much. But these take a while to work with to sort of understand what they do.